When installing rigid metal conduit into the side of a rain-tight panel, the use of seal-tight locknuts is a necessary practice to maintain the integrity and rain-tightness of the enclosure. The primary reason for using seal-tight locknuts in this application is to create a watertight seal between the conduit and the panel. Rain-tight panels are designed to protect electrical components from moisture and environmental factors. If a standard locknut is used without any sealing properties, water can seep through the connection point, potentially causing corrosion, electrical faults, and equipment failure. Seal-tight locknuts are specifically designed with a rubber or neoprene gasket that compresses against the surface of the panel when tightened. This compression creates a barrier that prevents water from entering the enclosure. This is particularly important in outdoor or wet locations where the panel is exposed to rain, snow, or other sources of moisture. The National Electrical Code, or NEC, provides guidelines for proper installation and sealing of electrical enclosures to ensure safety and prevent damage. While the NEC doesn't explicitly mandate the use of seal-tight locknuts in every situation, it emphasizes the need to maintain the rain-tight integrity of enclosures that are designed to be rain-tight. Using seal-tight locknuts is a common and accepted method to achieve this. Proper installation of seal-tight locknuts is crucial for their effectiveness. Firstly, ensure that the surface of the panel around the conduit entry point is clean and free from any debris or damage that could compromise the seal. Secondly, insert the conduit through the knockout in the panel and then slide the seal-tight locknut onto the conduit. Thirdly, tighten the locknut securely against the panel using appropriate tools. Do not over-tighten the locknut, as this could damage the gasket and reduce its sealing capability. It is important to follow the manufacturer's instructions for torque specifications. In addition to using seal-tight locknuts, consider applying a suitable sealant or thread compound to the conduit threads before installation. This can provide an extra layer of protection against moisture ingress, particularly in harsh environments. The choice of sealant should be compatible with the materials of the conduit, locknut, and panel to avoid any adverse reactions or degradation over time. Regularly inspect the seal-tight locknuts and conduit connections to ensure they remain tight and free from corrosion. Over time, vibration, temperature changes, and environmental factors can cause the locknuts to loosen or the gaskets to deteriorate. If any signs of loosening or damage are detected, promptly tighten or replace the locknuts to maintain the rain-tight seal. Proper grounding and bonding practices should always be followed when installing rigid metal conduit. Ensure that the conduit is properly grounded to the electrical system to provide a safe path for fault current in the event of a short circuit or ground fault. This is essential for preventing electrical shock hazards and protecting equipment. In summary, when using rigid metal conduit to enter the side of a rain-tight panel, seal-tight locknuts are necessary to create a watertight seal and maintain the integrity of the enclosure. Proper installation, regular inspection, and adherence to relevant codes and standards are essential for ensuring the safety and reliability of the electrical system. When selecting seal-tight locknuts, it is important to consider the specific application and environmental conditions. Different types of seal-tight locknuts are available, each designed for specific purposes. For example, some locknuts are designed for use in corrosive environments and are made from materials that are resistant to chemicals and other harsh substances. Others are designed for use in high-temperature environments and are made from materials that can withstand extreme heat. It is also important to consider the size and type of conduit being used when selecting seal-tight locknuts. The locknuts must be compatible with the conduit in order to create a proper seal. Refer to the manufacturer's specifications to ensure that the correct locknuts are selected for the application. In addition to seal-tight locknuts, other types of sealing methods can be used to maintain the rain-tight integrity of electrical enclosures. For example, sealing washers can be used in conjunction with standard locknuts to provide a watertight seal. Sealing washers are typically made from rubber or neoprene and are designed to compress against the surface of the panel when a locknut is tightened. Another option is to use a sealant or caulk to seal the conduit entry point. This method is typically used in situations where it is difficult to use seal-tight locknuts or sealing washers. The sealant should be applied carefully to ensure that it completely fills the gap between the conduit and the panel. Regardless of the sealing method used, it is important to regularly inspect the connections to ensure that they remain watertight. Any signs of leakage should be addressed immediately to prevent damage to the electrical components inside the enclosure. The NEC also provides guidelines for the installation of electrical equipment in wet locations. These guidelines specify the types of enclosures and wiring methods that are required to protect electrical equipment from moisture. It is important to follow these guidelines to ensure that the electrical system is safe and reliable. In addition to the NEC, other standards and codes may apply to the installation of electrical equipment in specific locations. For example, local building codes may have additional requirements for electrical installations. It is important to be aware of all applicable codes and standards and to follow them carefully. Proper training and certification are essential for individuals who install electrical equipment. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely. Many organizations offer training and certification programs for electricians. Completing these programs can help to ensure that individuals are qualified to install electrical equipment in accordance with applicable codes and standards. In conclusion, the use of seal-tight locknuts is crucial when installing rigid metal conduit into the side of a rain-tight panel to maintain the integrity of the enclosure and prevent water ingress. Careful selection of appropriate materials, proper installation techniques, and regular inspection are vital for ensuring the safety and reliability of electrical systems in wet or outdoor environments. Adherence to the National Electrical Code and other relevant standards is paramount for compliance and safety. Furthermore, continuous learning and professional development are important for staying updated on the latest technologies, best practices, and code requirements in the electrical field. This ensures that installations are performed safely, efficiently, and in accordance with the highest standards of quality. Firstly, understanding the purpose of raintight enclosures is essential. These enclosures are designed to protect electrical components from environmental factors like rain, snow, and moisture, which can cause corrosion, electrical faults, and equipment failure. Secondly, choosing the right type of seal-tight locknut is crucial. Factors such as the size and type of conduit, the material of the panel, and the specific environmental conditions should be considered when selecting seal-tight locknuts. Thirdly, proper installation of seal-tight locknuts is critical for ensuring a watertight seal. This includes cleaning the surface of the panel, applying sealant or thread compound, and tightening the locknuts to the manufacturer's specifications. Fourthly, regular inspection and maintenance of seal-tight locknuts are necessary to ensure they remain tight and free from corrosion. This includes checking for any signs of loosening, damage, or deterioration, and replacing the locknuts as needed. Fifthly, following all applicable codes and standards is essential for ensuring the safety and reliability of electrical installations. This includes adhering to the National Electrical Code, local building codes, and any other relevant regulations. Sixthly, grounding and bonding practices should be followed to provide a safe path for fault current in the event of a short circuit or ground fault. This is essential for preventing electrical shock hazards and protecting equipment. Seventhly, proper training and certification are important for individuals who install electrical equipment. This includes completing training programs, obtaining certifications, and staying updated on the latest technologies, best practices, and code requirements. Eighthly, using additional sealing methods such as sealing washers or sealant can provide an extra layer of protection against moisture ingress. These methods are particularly useful in harsh environments or in situations where it is difficult to use seal-tight locknuts. Ninthly, considering the specific application and environmental conditions is crucial when selecting seal-tight locknuts and other sealing methods. Factors such as the presence of corrosive chemicals, extreme temperatures, or high levels of vibration should be taken into account. Tenthly, staying informed about new technologies and best practices in the electrical field is essential for ensuring that installations are performed safely, efficiently, and in accordance with the highest standards of quality. This includes attending industry conferences, reading trade publications, and participating in continuing education programs. By following these guidelines, electrical professionals can ensure that rigid metal conduit installations in raintight panels are safe, reliable, and compliant with all applicable codes and standards. The use of seal-tight locknuts is a critical component of this process, and proper selection, installation, and maintenance are essential for achieving a watertight seal and protecting electrical equipment from the elements.